Just over a year ago, I made this Spiderman suit up effect, and like any other superhero related stuff, it is time for the sequel. We are going to create a procedural web shooter setup inside Blender. By the way, if you are a complete beginner to geometry nodes, this might not be the video for you. There are quite a few beginner friendly geometry node projects you can check on my channel. So let's get started. Today I will use Blender 3.5 Alpha, but you don't need the alpha version. Everything we do here can be done inside Blender 3.4 as well. Here I have a few things already set up. I have this environment collection which contains two simple meshes. This is where our web going to attach. Then I have this web shooter collection which contains two empties. One for our web shooter location and the other one to specify where in the environment we want to shoot our web, the target. You can add them simply by hitting Shift A and selecting any of these empty objects. We got a web shooter, target and environment. Now we need our web. To create that in the web shooter collection, I add a mesh plane. Rename it to web. Go to Geometry Nodes workspace and add a Geometry Node modifier. You can add that either from Modifiers tab or from here in the Geometry Nodes editor. I call it Web Shooting and pin it. We don't need the initial connection. We are actually going to create the web shooting setup in reverse. First, we are spreading some points in the environment and spawn some curves from there. Then attach the other ends of each curve to the web shooter. After that, we do few more stuff to make it look like a web. So, we will start by creating some points around this target object. We can do this using two methods. Both are handy in different situations. Right now, I use the longer method, but later in the video, I will teach you the much simpler method. Sounds good? Let's add a points node. Actually, in the latest 3.5 alpha builds, our nodes have a different but better organization in the add menu. So this will probably take some time to get used to. But if you know your nodes, you can always search for them. I will add about 20 points. Plug this into the output. You can hit Shift or left click to quickly do this. But for some reason it is not working for me in this version, so I'll manually plug it this way. Now all of our points are in the exact same location. Since I want them around the target object, I drag and drop the target object to the setup. Set it to relative and plug its location into position socket. This will bring all of our points to target's location. But still, all the points share the same location. To randomize them, I drag from the target's location and add vector math add node and plug a random value node into the second input. This gave the points a random position in the positive X, Y, and Z directions. to spread them in the negative direction, I set the min x and z to -1. I keep the min y at 0 because we are shooting from this direction and I want to spread the points away from the web shooter. This will give a bit of a cone shape for spreading, but it will create an issue when we are shooting from other directions. We will fix that later. Right now, let's just keep it this way. To increase and decrease the spreading of the points, I add a vector math node here and change it to scale. We can use this second input to increase or decrease the spreading. To make it even easier, I hook the scale of the target object to this scale socket. This way, we can control the spreading by simply scaling up or down the empty inside the 3D view. And also, you can use this seed value to further change the randomization. Let's select all of these nodes and hit Shift P to frame them. I like things organized because they easily can turn into a mess. Call it points. You can change the frame settings from here. Our next step is to attach these points to the nearest surface in the environment. To displace any geometry, we always use set position node. To create a reference to our environment collection, I drag and drop the collection to the setup. Set it to relative. To find nearby geometry, we can use geometry proximity node. Let's use our collection as the target and plug this position to position socket. Not working, and we are getting an error here because instances will not work with proximity node. We need meshes. So to fix it, add a realize instances node here. This will turn our instances into mesh geometry. It is working now. Make sure to set this to faces because we are trying to find the nearest surface, not the points, not the edges. You can see it is working well. It finds the nearest surface and gives that position to the point's position. Organize this as well. To create the webs from these attached points, let's add instance on points node. For the instance, let's use quadratic Bezier node. We only need 3 points, so set this to 3. Hey, it's me from the future. I made a huge mistake here. This resolution means the number of edges, not points. This also means right now I have a 4 points curve instead of 3. Don't worry, I will realize this later in the process and we'll fix it. But until then, just think of this as a curve which has 3 points. It doesn't matter what you set in this start, middle and end inputs. You can ignore them. But just for now, I set them like this, only because it will probably help you to understand better. So we have 20 curves from our points. Our next step is to take the endpoint of each curve and plug them into the web shooter. But before that, I add realize instances node and convert these instances into actual curves that we can displace. So to hook the endpoints to the web shooter, I add a set position node. Drag the web shooter object to the setup. Set it to relative and use its location for the position. This will make every single point in all the curves go to the web shooter's location. But we want only the endpoints to do that. To select only the endpoints of each curve, I can use endpoint selection node. This allows me to make a selection of points from each end of the curve. Right now, the starting point of each curve is attached to a point on the surface. We don't need to mess with that. All we need is the endpoint. So I set the start size to 0 and end size to 1 and drag the output to the selection socket. Now you can see we are displacing only those points. Let's put the web shooter location to the position. Frame this. Now let's take care of the middle point of the curves in a similar fashion. I want to use them as the spreading point when we are shooting the webs. Add a set position node, then add endpoint selection node. We don't have a way to select our middle points directly, but what we can do is we can select the two endpoints of our curves and then inverse that selection. To take the inverse of the selection, I add a not boolean math node. This gives us the middle point. Now plug this into selection. This way we can displace the middle points without affecting endpoints. Now I add our target object to the setup. Set it to relative and plug its location to position. It is working, but it doesn't look good, isn't it? Our spreading point is very static. You can see that issue clearly when I change the location of the web shooter. I like to have a more dynamic spreading point, which reacts to the changes in the web shooter and our target. For that, I will do a few vector calculations. To make it easier for you to understand, I put my web shooter in 0, 0, 0. Let's put the target over here. Now drag and drop both empties to the setup. Set them to relative. Then I subtract the web shooter's location from the target object location. What this does is it gives us another vector that parallels the direction from shooter to target. If you switch these two input, it gives us the opposite way. So make sure to subtract web shooter from target. Also, that vector has a scale that matches the distance between the web shooter and target. This means if I plug this to position right now, it will give us the same results like before. But now I can add a vector math scale node after this and change the spreading point location in the right direction, which also gives this stretching look to the webs. I like to keep this value around 0.8. But this setup struggles when I move the web shooter. To prevent that, we need to add the web shooter location back into this. And just like that, we got our spreading point to work nicely. Shift P to frame this and I call it spreading point. Let's create the shooting mechanism. It is very simple. Just add trim curve node. When we change the start value, we can create the shooting effect. But right now, we have to change that value to go from 1 to 0 for shooting effect. I don't like it. I want my shooting effect to work when this value go from 0 to 1 instead of 1 to 0. For that, I drag from here and search for subtract math node. Change the first value to 1. Now, when I change the second value from 0 to 1, we will get the shooting effect. You know what? Let's extract this one now. We need the group input node. Since I didn't delete that at the beginning, I can use that one, but here I just delete it and add a new one. I want a slider input for our shooting. To create a slider input, all we have to do is drag from a slider input like this end input and connect it to the group input. This will create a slider input that goes from 0 to 1. Remove that connection. Now plug that socket to the second input in the subtract node. And like that, we have our shooting mechanism accessible in the modifiers tab. You can rename the extracted input name from here. We have the basic web shooting setup. Now it is all about making it more like a web. But for that, we need a lot more points in the curves, more than 3. To add more points to our curve, we can use 𝒕𝒉𝒐𝒖𝒓 node. Let's add about 20 points for now. This also changes the spreading point a bit, and I like it. So let's fix this issue without messing up anything. What we need for our instance is a curve with 3 points. So I delete the previous quadratic Bezier node and add a curve line node. This creates a curve with 2 points. To make it a curve with 3 points, I add a resample curve node and set the count to 3. Now you can see it is working. We have 3 points in each curve and we have 20 curves, which means altogether 60 points. After the resample curve here, we have 23 points in every 20 curves, which gives us 460 points. You can see that number here in the spreadsheet. Okay, let's add some noise to the curve. I add another set position node and plug a noise texture to offset. This will give our web some displacement. You can change the noise texture settings to your liking. Noise texture outputs only positive values. Because of that, our web is only displacing in positive directions. To prevent that, I add a map range node and map the 0 to 1 values coming from the texture to -1 to 1. Then add a scale node to control the strength of the noise effect. Usually I keep this value around 0.1. But since we are adding the displacement to the whole web, this also messes up our attaching points. To prevent that and add more smooth displacement around each end, I use spline parameter node. This factor value will give us a 0 to 1 value range along the curve. Add a float curve and change it to something like this. Using this, we can add 0 displacement to each end and full displacement to the middle parts. Now plug this into a multiply node and plug its output into scale socket. You can smooth out the displacement like this if you want to. To smooth our curve points, I add a set spline type node and change the spline type to NURBS. This will smooth out those rough displacements. Now it is time to create the secondary webs. Later I join them with our primary web shooter setup we just created. So let's add a join geometry node. Put it here. We don't need that just yet. To create the secondary web, I will use this part of the web setup. To get only that part, we have to delete the rest of the setup. So add delete geometry node. This will delete everything by default. So how do we keep only this part of the setup? Right now we have 30 points in each curve. We can use that number. I add an index node, then plug a modulo math node into it. Type that number 30. Now what this does is it divides our index by 30 and outputs the remaining, which gives us this 0 to 29 pattern along the curves. Then I add another math node and set it to divide our primary web resolution 30 by something like 3. 3 will work in most cases, but depending on your web setup and shooting distance, you can increase or decrease that value. Now, I add a compare greater than node and plug these two inputs and plug the output to the selection socket. You can see it deleted that part of the web. What happened was, it looked at every number coming from the first input and checked whether it is greater than to the second input value. In this case, 30 divided by 3, 10. If a particular point's number is true to that logic, then that point will get deleted. But your number may not be 30. It could be 31, and in that case, we are outputting a float number, 10.33, like that. It is okay to have that. This logic will still work. But I always like to keep things in a particular way. So I add another math node here and select float or round math type. This will turn that float number into an integer. Now I add a curve to points node. Then I add an instance on points node and use a curve line as the instance object. Let's frame this. I join this with our previous setup. You can see all we have left to do is hook these endpoints of the secondary webs to another place in the primary web. Like before, first we need to realize the instances and then add a set position node to displace the points. To select only the endpoints, I use endpoint selection node. Then I add geometry proximity node. This will help us to find the nearest point. So I connect this target input with this curve to points node. You can shift right click, drag on the noodle to create reroute nodes. Now I plug this into position and change the type to points. It doesn't look that bad, but we can make it better by simply altering the source position. For that, add a position node and then add a random value node to it. This will randomize our source geometry position. Set the min values to -1 and you can see it gives a better results. I know it doesn't exactly look like a web, but in motion and from a distance, I don't think anyone will notice anything wrong with it. And again, you can use the seed value to randomize it. After this, I do the same treatment I did to the primary web. Add more points using resample curve node. Duplicate the noise displacement setup we created earlier and use it here as well. You might have to turn down the scale. Smooth the curve. And that's our web shooting setup. To finalize this, we have to turn this into an actual geometry we can see in the render. For that, add curve to mesh node and add curve circle node. A resolution of 3, 4 or 5 is more than enough for a web setup. You don't need to go higher. Plug it as our profile curve. As you probably guessed, we have to turn down the radius. I use something like 0.001 meter. Now let's add a material. Add set material node and create a material over here and assign it to the web setup. Then in the materials, I give a bluish white color and roughness of about 0.3. I increase the IOR value just a bit and set the transmission to 1. Give some transmission roughness as well. Then add an edge shader node and plug translucent BSDF. This will catch the light perfectly and will give that web look. Darken the translucent color just a bit. And that's how we created a web shooting setup inside geometry nodes. Now let's do some troubleshooting and finalize this. Since we randomized the position of the attaching point in a specific direction, you can see it not really working well on all occasions. To fix that, I am going to link the rotation of our target object to the points. For that, let's add set position node. To make them rotate, I add a vector rotate node and plug the vector output into position. Set the type to Euler. For the first vector input, plug the position of our points. And for the next input center, we have to specify the pivot point of our rotation. And that should be the location of the target empty, because I vote my points to rotate around it. And for the rotation, I use the target's rotation. Now you can see our points are rotating with the target object. But if you don't like to do this manually, what you can do is adding a track to constraint to our target object. Select the web shooter as the tracking target. Set the track axis to -y and up axis to Z. This will automatically rotate the target object towards the web shooter. But this will always rotate the target object, which might not what you want. In those cases, you can either delete or hide that constraint or animate its influence. Now to that second method of distributing points. Our current setup is good if you are shooting into a static object like walls. But if the object you're shooting at starts moving, you might face some flickering, like a helicopter or a person. In those cases, this second method will help you. For this, we don't need the first two steps. Drag and drop the environment collection. Set to relative. Realize the instances and add distribute points on faces node. Now, using the vector math distance node, calculate the distance between the location of the target object and the position of each point. To select the points inside the target empty, use greater than node and plug the empty scale to the second input. This will give us a selection for every point outside the target sphere. Then using delete geometry node, we can delete all of those points. You can use the density to control the amount of attaching points. Let's call this method 2. You can also use mesh to points node instead of distributing points on faces node. So that's it. That's our web shooting effect inside Blender's geometry nodes. If you want to take a look at the project files and a more polished, finalized web shooter setup, feel free to become a Patreon member. Or you can grab the GeoNode setup from my Gumroad page. And special thanks to these amazing individuals for making these tutorials possible. So, I hope you learned something cool, something new. That's what we like to do. We not only create stuff, we let you create with us. Hit that like button, comment your thoughts below, and don't forget to subscribe to HellFX Learn so you won't miss out when the next video drops. Until next time,